Sitting here with Rob Friedland. He is a neurology professor at the University of Louisville, and he has a special interest and does a lot of research on Alzheimer's disease and what some of the causes and effects of Alzheimer's are. Rob, thanks for being on the show again. I appreciate you being on.
Thank you, Mark.
All right, Alzheimer's. What is it? Everybody seems to know what Alzheimer's is, but how do you describe it?
It's the most common cause of dementia in the United States and around the world. It affects a large proportion of people over the age of 65, nearly 40% of people over the age of 80. And it causes an irrevocable loss of recent memory and trouble with language and perception and finding the way around and abstraction and judgment.
And when we have talked in the past, you do specific studies, and you have done a specific study on how your diet and the bacteria in your gut impact what's going on in your brain. So why don't you talk about that a little bit?
Yes. So our work and work of many other people, work we did previously in Cleveland and work by others around the world, shows that the diet has an influence on the disease, and it is beneficial to have a diet with relatively low fat, relatively low amounts of meat, and more fruit and vegetables, and brown rice, and high in fiber.
So some folks would say, how in the world can what you eat affect what's going on in your brain? What do you tell them?
Well, lipid metabolism is important for the function and structure of blood vessels in the brain and for neuronal membranes. So it's bad to have too much fat, particularly saturated fat. Also, we are home to countless populations, a virtual ecosystem inside the gut, including the mouth, nose, and intestines, with millions and trillions of bacteria and other organisms. And these organisms influence our digestion, metabolism, immunity, and resistance to infection.
Okay, so that plays into the whole, it's not just Alzheimer's and dementia, it's other things as well that gut bacteria and microbiota can impact.
Exactly. It's also related to heart disease and stroke and cancer.
So I'm assuming the same diet's good for the low-fat diet, very little meat. It's good for all those things.
Absolutely.
Or good to keep those things away.
That's right. And our research in animals implies that there are also relationships between what the intestinal bacteria are doing and the generation in the brain of Alzheimer's and Parkinson's, as well as ALS or motor neuron disease.
We're talking with Rob Friedland, who's a neurology professor at the University of Louisville. We're talking about Alzheimer's disease, which he has done extensive studies on. What is the progress being made as a whole on Alzheimer's disease and figuring out the causes and figuring out how you might slow the process of Alzheimer's?
Well, there have been decades of research on a particular protein in the Alzheimer's brain, which is called amyloid beta.
Right.
And the emphasis has been on having it removed. And for over 20 years of research on immunotherapy for this purpose have not yet produced any viable results showing any beneficial effect of removing this protein. However, new work shows that the protein itself may not be the disease-causing agent. It may be the inflammation which elicits the amyloid production. And we believe the inflammation is originating through the influence of bacteria that reside in the gut. So
all those years of work on this amyloid, you hate to call it wasted, because obviously that a lot of research goes down a rat hole and you never figure it out, but that didn't turn out to be what was causing Alzheimer's, right?
It really was never clarified exactly what was initiating it.
Okay.
It was the story that there is this amyloid and this amyloid does these bad things, but how that was created in the first place is not clear. We believe it is a response to metabolites or proteins made by bacteria that live inside us that creates both the amyloid itself as well as an enhanced inflammatory reaction to it, which leads to degeneration.
So has the research on microbiota and what's in the gut in animals. Has you been able to reproduce that in humans yet? Are we that far along in the research on, is that slowing the process of Alzheimer's in humans or just in animals so far?
We are working on applying these methods to studies of humans with Parkinson's disease and planning studies in regard to Alzheimer and other conditions.
So look into your crystal ball and tell me, when might we know what's causing Alzheimer's in humans? Are we 5 years away, 20 years away, 2 years away?
It's not possible to predict the future in science, but there is remarkable new evidence that these organisms, which are our partners, they were present in all of our ancestors, and we evolved with them, and they evolved with us. There's enormous evidence that they are playing an important role in our health and disease.
Talking again with Rob Friedland, who's a neurology professor at the University of Louisville, does research on Alzheimer's and other head diseases and brain diseases. How do you know when you have Alzheimer's? I mean, if I'm 58 years old. How the heck do you know?
The main symptom in Alzheimer is forgetfulness, but it is a forgetfulness that is beyond the everyday forgetfulness. So forgetting in itself is normal. If I go to work and go home and can't find my car in the parking lot because I parked on the 4th instead of the 3rd floor, that's what I consider normal forgetfulness.
Yeah.
If I take a taxi home because I don't remember that I drove in the morning, that's more than normal forgetfulness.
I got you.
Forgetfulness in itself is normal, and it's also more common in persons over the age of 50.
Gotcha. Okay. Well, I'll ask you more off the air because I've got some questions about it, because my memory, as I'm getting a little bit older, has gotten worse. I don't remember names as well. I don't identify objects as quickly when I say, "Hey, Rob, could you hand me that thing over there? The fork. The fork. That's what I meant to say. Is that a sign that I may be losing it?"
No, that's rather universal.
That's a part of getting old, right?
If you put it in the microwave along with your shoes, then that might be a problem.
All right. Well, I won't do that. I haven't done that yet. All right. I want to talk to you about something else that we talked briefly about the last time you were on the program. CTE, the head trauma in NFL football players. There was this huge study that found, I think, 98% of the NFL players who had autopsies and had their brains dissected after they died, it was found to have CTE, traumatic stress on their brains. Where are we on CTE, and how bad is it in athletes?
Well, the research has shown out of 211 NFL veterans who died from various causes, 210 of them had this condition, chronic traumatic encephalopathy, which is a neuronal degeneration caused by abnormal buildup of proteins and the death of nerve cells, which is associated with memory loss, dementia, sometimes suicide, aggressive behavior, irritability, and depression. And it is irreversible and untreatable. In another study of 68 college football players who died from various causes, 58 of them were found to have this. So we know already that it has a very high incidence and prevalence in men who play football.
And helmets obviously aren't helping, presumably.
There is no way to protect the brain from repeated head injuries, because even if it's in a very perfectly designed and well applied helmet, if there are forces applied to the helmet, some of those forces are going to make it into the head, and the head is not designed to withstand injuries. Unlike the brain or the skull of a woodpecker, which is made to do that because that's the way they evolved, that's what they do for a living. We don't have any functional purpose of injuring the head.
And the brain rattling around inside our skull, right?
And the brain rattling is not good. So it is Hippocrates who said there is no injury to the head that is too trivial to be despised. So it's not only the really big injuries like concussions, which are bad for you, even the relatively minor ones, which don't cause loss of consciousness, which are repetitive, which happen as a basic fact in almost every play in a football game.
So for every parent out there that's listening to this program and has maybe a teenager or a young child that wants to play football, is there an age where you can say, I wouldn't let them touch a football and bang heads with tackle football and bang heads with another kid until age blank? Or would you just say, as a neurologist, I'd never let them play football?
I think the evidence is very clear that children should not play football. And adults can make their own decision, but I don't think anyone should play football because it is associated with serious, repetitive, heavy and less intense injuries to the head, and the risk of this untreatable degenerative disease is too high to accommodate. And the other part is it's not necessary to play football. Children can play tennis, baseball, basketball. They can do countless other things which don't involve head injuries.
What about soccer and lacrosse, two sports that where you do have occasional head injuries, but not the repeated head trauma that you do with football?
Right. Again, the head was not designed to be an instrument to influence the propelling of a spherical object.
In other words, headers in soccer are bad.
It's not a good thing, and there is scientific evidence that soccer players have neuronal proteins in the spinal fluid that don't belong there.
Okay.
And it's just not particularly a good thing for the brain. And it comes down to basically a high level of respect for the brain, because it is, in essence, the nature and the home of our self, of our emotions, our spirituality, our ability to do anything, whatever it is we're doing, and we need to take care of it.
Okay. Rob Friedland, neurology professor at the University of Louisville. Always fun to have you on the show, and
Thank you,
always
Mark.
interesting chats.
Thank
All right,
you, Mark.
appreciate you being on.